Today we're going to be reviewing again inequalities and direct variation. So these are two topics that you already know way too much about, but we want to make sure that we're going to do super well on that test. So we're going to review these. Today the focus is going to be solving direct variation problems as well as writing inequalities. So we're not necessarily going to solve them or look for solutions. We talked about that last class period. But we are going to talk about these word problems. We want to make sure that we can take all of the words that people can give us and we convert them into math symbols. So let's go ahead and jump in and get started. All right. So, of course, anytime we're dealing with inequalities, there's going to be certain words that go along with each symbol. So, for greater than, an example of that would be something like more than, exceeds, or is over. However, for less than, we would use words like less than, obviously, under, or fewer than. For greater than or equal to, we would use words like at least, no less than, or is not under. However, for less than or equal to, we would use words like no more than, at most, or does not exceed. All right, so let's go ahead and take a look at the very first example. So, here I see the manager of a local burger restaurant projects that the restaurant should achieve more than $10,000 in revenue from burgers and fries every day in order to remain profitable. Its burgers sell for $5, fries for $3. Write an inequality in standard form that describes the situation. Let X represent the number of burgers sold and Y represent the number of fries. Okay, so burgers are X, fries are Y. And here they said more than 10,000. More than. So, whenever I say the word more than, I would say, all right, can I have all the different numbers that are right around there? So I say, is 9,999 more than 10,000? No. Is 10,000 more than 10,000? No. Is 10,001 more than 10,000? Yes. So, because this guy is not included, we do not have the extra line. So, we would write our equation like this. Our keywords here were more than, and we used this symbol. All right, example 2. As part of a landscaping project, Mr. Ramirez is purchasing plants from a garden center. It will cost $20 to buy a mature tree, $10 for a young one. His target is to keep the cost under $1,300. Write an inequality in standard form that describes the situation. Let X represent the number of mature trees and Y represent the number of young trees. Okay, so here they told us X is mature, Y is young. So I know for sure that the first part is going to be this, and it's going to have some kind of relationship to 1,300. So I'm just going to write out my numbers for illustrative purposes. So they want me to keep the cost under 1,300. Is 1301 under 1300? No. Is 1300 under 1300? No. Is 1299 under 1300? Yes. And the process that I just went through is something that you would do with domain and range when it comes to these, okay? So, for this particular one, because this guy is not included, I do not have my extra symbol. My extra line. My keywords are going to be under. And we're going to use this symbol that tells us less than. Now, had they have said no more than, or at most, or does not exceed, then we would have assumed that there would have been an extra line because we could have spent up to $1,300. All right, next one. Genesis is inviting people to her quinceañera and wants her food budget to not exceed $4,500. The cost will be $45 for each adult meal and $15 for each child meal. We're going to make X represent my adults. Y is going to be for my kids. So first thing I'm going to do, I'm going to go ahead and write out that first part. I'm going to go ahead and put in my number. All right. So now I ask myself, 4,500. Okay. So, can I spend 4,501? No. Can I spend 4,500? Yes. Can I spend 4,499? Yes. So less than or equal to, because this is included in this. My keyword was not exceed. And we utilize this symbol. All right. So moving on to direct variation. So, just as a preface, we are going to fill all of this in. However, I just want you to remember direct variation means we're just straight multiplying. This is a y equals mx plus b where you do not have a b value. Okay? That's all it is. Y equals mx plus b where your b is equal to 0. So, a direct variation is another name for what is called a proportional relationship. Proportional relationships pass through the origin 0, 0, which means their y-intercept is always 0, 0. A direct variation can be written as an equation in the form of y equals kx. That's really just an m, a slope, where k represents what is referred to as my constant of variation, also known as my slope or sometimes my rate of change. All right. So, take a look at these two. I automatically know that this first one does not direct variation because it says 0, 2. So this one is not. This one goes through 0, 0. This one is. Okay. Because I'm looking at whether or not it has the origin in it. Okay. So table B is representing my direct variation, and its constant of variation is, well, let's look. I can't tell there. Times 5, times 5, times 5. Okay, constant of variation is 5. Now, these direct variation word problems and solving for them is kind of a tricky business, but that's okay. It is something very simple, and typically, what I'm going to say before getting into this is that because you use this formula, the reason that people like to do it with the y on top whenever you're talking about different sets of points is because the way this formula is set up. Because this is proportional, you don't necessarily always have to put this in the same order, but you do have to make sure the y's are either both at the top or both at the bottom. The x's are either both at the bottom, both at the top, okay? So, all right. So we can solve direct variation word problems by setting up proportional proportionalities. There we go. Proportionalities. To solve, and I'm going to cheat a little bit here. To solve proportionalities, we need to cross multiply, then divide. All right. So, now, how do you figure out which one is which? Always put the ones that have the same units as the same x or y, okay? So, if Tom runs 4 kilometers in 1/2 hour, how many minutes will it take him to run 10 kilometers? Okay. So, first thing, they have a lot of different units going on. Here's hours, here's minutes. I'm going to change that into 30 minutes because I'm looking for an answer in minutes. So he ran 4 kilometers in 30 minutes. How long is it going to take him to run 10? Well, I don't know which one is X and Y, but what I'm going to do is I'm going to go ahead and put the ones that I do know for sure, both of them. I'm going to put them at the bottom, and then I'm going to put my time at the top, and I'll just call this one X. Now, the reason why I do this is because guess what? If I just multiply by 10 and get rid of this divisor, I'm completely done, okay? So over here, I'll multiply both sides by 10, and I get X equals 300 over 4. And I find out it's going to take them approximately 75 minutes to run 10 kilometers. So pretty simple. I could have also cross-multiplied, and I would have gotten 4x equals 300 divided by 4, and I would have ended up right at the same exact place. The reason why I do this is because it's just one less step. This makes it easy. It sets it up automatically like that, okay? So, next example. If y varies directly as x, when x is equal to 6, y is equal to 4, what is x equal to when y is equal to 15? All right, so I am going to say, I know my 2 y's, so I'm going to put those guys at the bottom. This is the y that does not have an x paired with it. And here's my associated x. I can just go ahead and multiply by 15 on both sides. And I end up with this. So I'll go ahead and keep on simplifying this. And I end up with 22.5. Now, I want to go ahead and do it the traditional way with the y's on the top. So I would say 4 and 15, x, 6. I would cross multiply. Divide by 4. And I end up right back at the same exact place. Okay? So, I want you guys to go ahead and take a look at this example question, and I will see you next time.